So let us first take a very simple example of hydrochloric acid or simple hydrogen chloride, HCl. When I'm writing HCl, it is hydrogen chloride, and if I write HCl aqueous, then that becomes hydrochloric acid. So write down the electronic dot structure or the Lewis dot structure for HCl. For that, again, it's very simple. We first count the number of valence electron. One from hydrogen, hydrogen has only one valence electron, and whereas chlorine belongs to the 7th group and it has 7 valence electron, and even if you look into its electronic configuration, it's 3s2 and 3p5. So in the third shell there are 7 electrons. So there are 7 valence electrons. So in total HCl has 8 valence electron. So that means when I'm writing electronic dot structure for HCl, I need to arrange 8 electrons around an HCl. So HCl is a diatomic molecule. Over here it doesn't matter which is a central atom, which is a terminal atom. They all are linear. All diatomic molecules are linear. So then the first step what I have shown is I have joined a hydrogen with a chlorine with a single bond, and single bond, as I have already discussed, represents a pair of electron. That means one electron is coming from hydrogen, another electron is coming from chlorine, and they are being shared between the two nuclei. So this is a bonded pair, right? In the next step, I have to arrange electron in such a way that the octet on the chlorine is complete. So why I'm talking about the octet on the chlorine? There are two reasons. First, hydrogen can have a maximum of only 2 electrons, because in the first shell there is only one subshell and only one orbital, and in an orbital you can have a maximum of only 2 electrons, and it already has that. The second is the most electronegative element, the most electronegative atom in a molecule, its octet should be completed first, and then we are going to consider if there are left for the atom in the molecule which is less electronegative. So comparing the electronegativity of hydrogen and chlorine, hydrogen is 2.1 electronegativity, chlorine is 3.0 electronegativity. So chlorine is more electronegative. So my first job is to complete the octet on chlorine. So when I do that, 1, 2, 3, 4, 5, 6, 7, and 8. All the 8 electrons have been accounted for. The octet is complete. So this is an electronic dot structure for HCl. Very simple. Another simple molecule to write the electronic dot structure is F2, which is a fluorine molecule. A fluorine molecule is composed of 2 fluorine atoms. So how many valence electrons we are seeing? Fluorine, again, just like chlorine, belongs to the 7th group. It has 7 valence electrons. So there are 2 fluorine atoms. Each fluorine atoms has 7 valence electrons. So in total, for the fluorine molecule, you have 14 valence electrons. You have 14 valence electrons. So when I'm writing the electronic dot structure for fluorine, very simple. You have fluorine attached to another fluorine. So 2 electrons are already being considered. In the next step, you have to make sure that the octet on each of the fluorine atom is complete. So 2, 4, 6, and 8. 2, 4, 6, and 8. So the octet is complete. In total, how many valence electrons I'm seeing? 6 plus 6 is 12, plus 2 is 14. So 14 valence electron. So that's the electronic dot structure for fluorine. And if I ask you which are the bond pair and which are the electron pairs, or I can even ask how many bond pair and how many lone pair of electrons are there in a fluorine molecule, that's very simple. This here is a bond pair, means 2 electrons. So there is only one bond pair of electron. One bond pair. Pair means 2. There's only one bond pair of electron in fluorine molecule. And how many lone pair of electrons are there? How many lone pairs of electrons are there? 1, 2, 3, 4, 5, 6. So there are 6 lone pair of electron in a fluorine molecule.